So before we get started into day 4, which is rational exponents, which means the power is a fraction, before we get into that craziness, we're going to review some grade 9 exponent laws. Okay, so for example, what happens when you have the same base being multiplied with the different powers? Do you remember that? You're multiplying. They have same base, but different powers. What do you do with the powers? You add them. Good. Okay, so what's an example of that? 2 cubed times 2 to the 5. 2 to the 8. Why is it 2 to the 8? How many 2's are there from the cube? Good. And how many 2's are there from the 2 to the 5? Oops. So altogether you have 2 to the 8. That looks like 28. 2 to the 8. Okay. You just add up all the powers. You guys remember that? What happens when you divide? X to the A divided by x to the b. So now you subtract. Okay, so let's do an example of that. So I'm going to have to erase this. Let's do an example of that. So let's say you had 3 to the 5 over 3 to the 2. So what's the answer to this one? 3 to the 3. Why? Why? How many on top? And how many on the bottom? And then when you're dividing things that are identical, they just cancel, and you're left with 3 of them. So you have 3 3's. So this would be the same as if you did 3 to the 5 minus 2, 3 to the 3. Okay, and there's one more exponent law that you should have been taught in grade 9. It's when you have a power raised to another power. Do you remember what you do for that? Well, we use plus, we use minus. What do you think we use now? Yeah, we times them. X to the AB. So you times them. X to the AB. Okay, and I'll put an example of that on as well. Let's say we had 2 to the 4 to the 3. So what should the answer be? 2 to the 12. Why is it 2 to the 12? Hold on, let's take a look at this. First of all, what do you do? Brackets first or exponents first? Okay, so brackets first. So what does 2 to the 4 look like? 2, 2, 2, 2. Now what does it mean to cube something? You repeat the base 3 times. So we have to repeat 2 to the 2 to the 2 3 times. So how many altogether are there? 12. 2 to the 12 would be the same as if you multiplied. So that would be the third exponent law that you should already know from junior high. And of course that was a long time ago, so I'm reviewing it for you. So these ones you should already know. Should. Keyword. Alright, so now we gotta try what happens if the power is a fraction. And it starts off with review of how to work with fractions, how to add and subtract them, and then how to times them. Okay? But for now, we'll skip that. That's like elementary stuff. Alright. So this chart here, do you recognize these numbers? What are they? They are the perfect squares. And do you recognize these ones? The perfect cubes. And then here they're going to use a power 1/2. Everybody see that? X to the 1/2. Okay. So can everybody try this in your calculator? 4 to the power 1/2. Four to the power 1/2. And if you're using a scientific calculator, you need to use brackets. You guys getting 2? Bailey, you're going to have to use brackets. Now try the next one. 9 to the power 1/2. 3. So what can you deduce about the power 1/2? It's the same as square root. Yes, very fascinating. Okay, so now let's take a look at these ones. The cubes. Try 8 to the power 1/3. What do you get there? 2. Try 27 to the power 1/3. What do you get? 3. So what can you deduce about power 1/3? Same as a cube root. So what do we notice? What's special about the fraction? You'd have to use the denominator. The denominator tells you what type of radical it's going to be. Okay? The denominator tells you what type of radical it's going to be. Let's try this one. X to the 2/3. 8 to the power 2/3. And of course I'm writing it how you'd write it in a calculator. That's not the proper way to write it mathematically. What'd you get for that? 4. Okay. Try the next one. 27 to the 2/3. 6? I don't think it's 6. You got 9, right? So what's the difference between 2 and 4? You have to go, and then 3 to 9. What's the pattern? Not timesing. It's powers. Okay, well, let's try the next one. 64 to the power 1/3 is 4. And then 64 to the power 2/3 is 16. So how do you go from 4 to 16? 3 to 9? Yeah, so the 3 here tells you it's a cube root. And the 2 here wants you to just leave it as a square. The numerator you just leave as a exponent. The denominator is the root of the radical. Okay. So that's like, what do you call this? This is just an exploration. We're just playing around with the numbers to try and figure out a pattern and a rule. Okay, that's just an exploration. On the next page, we'll formalize it. Here are our conclusions. What did we say about x to the 1/2? It was the same as a square root. The denominator of the fraction in the power, it's a lot of words, the denominator of the fraction in the power is the index of the root. And square roots, of course, you don't have to put the little 2 there, okay? So what would the next one be? X to the 1/3 would be the cube root of x. Is there another one? Oh, x to the 2/3. So for x to the 2/3, what do you put for that? The denominator is the root, so it's a cube root of x. And what do we do with the 2? It just stays there. Okay? So imagine it was just x squared. Well, it's just x squared, right? But it's not x squared, it's x to the 2/3. So you have to put on this cube root sign. So this tells you cube root. Alright, here's the general conclusion. X to the m over n. Help me out. How do I write this? Where does the n go? The denominator, where does the n go? It's the index of the root. So this is an nth root of x to the m. And if you can do this, you're going to get some free marks on the written response. This is a question. It'll be like x 2, 3, and you just got to put the 2 and the 3 in the right spot. That's free marks. Seriously. Okay? Yes. All right. Given a power with a decimal exponent, the decimal can be converted into a fraction which can be written as a radical. It looks like I have to make one up. 5 to the 0.2. Like, what does that even mean? Can you even do that? Yeah, these are irrational numbers usually. So it says you can write the decimal as a fraction. What is 0.2 as a fraction? 2 out of, how many fingers you got? Why is it 2/10? Well, we chose 10 because it's easy. Why is it 2 out of 10, guys? Because 0.2 is a tenth. Let's try another one. What if it was 5 to the 0.36? 36 out of 100. Okay. Then you can reduce this to the lowest terms, 5 to the 1/5. This one would be 5 to the, oh my gosh, 18 out of 50. Divide by 2. Looks like you can keep going. 9 out of 25. Okay. So the 5 to the 1/5 would be what type of root? A fifth root of 5 to the 1. Do I need to write the 1? No. Okay. And this one would be what kind of root? A 25th root of 5 to the 9. If the radicand is a number, you can evaluate a power with a fractional or decimal exponent. And those examples we'll do down here. So let's just do them. So see how this says without calculators? So put that down. You can use your chart though. So if you have your chart going, you're more than welcome to use your chart. If you haven't made your chart, then you're really starting to anger me. Your study sheet needs to be up to date. You can flip back in your notes. It's on page 4. It's right here. You can flip back in your notes. You need to get this chart on a study sheet with everything up to date by tomorrow, or else I'm going to be seriously upset. And yeah, I'll just get very, very angry. Turn green. Okay, so everyone's put their calculators down, and you got your chart maybe handy. You can flip back to it. All right. Okay, first things first, number 1, convert to radical. Okay, that's your first step, convert to radical. So, the first one. Is it a third root or a second root? Third root of 27. And what else will you do? Square it. Now I'm going to give you a little hint before we jump into this. Back up to the top of the page. This general conclusion, you can write it a different way. The order does not matter. You can take the nth root, find that first, and then do the power m. Either one is fine. You can do the power m first, like here, or you could do the nth root first. Okay, and I'll demonstrate that with this example coming. Does everybody have this? Okay, look at the question. Should I put the square on the inside? Does anybody know 27 squared off the top of their heads? That's a big number. So that's hard to do. So what I'm trying to get at is that you do the root first, because the cube root of 27 is easy. It's on your chart. Okay, so let's do that first, and then we'll square it after. Okay. So what's the cube root of 27 on your chart? Find the x column, the root, 3. You still need to square it. The answer is 9. So 27 to the 2/3 is 9. Make sure you can do that style of question by hand. You have to show the steps. If it was written response, hint, 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 wink, nudge, punch, kick. Wake up! Okay, next question. Is that a third root, a first root? Is that even possible? First roots? So that's a third root of -8 to the 1. Do I need to write the 1? No, you don't need to write that. Hold on, it's 2. -2. Is this real or non-real? Are you allowed to take cube roots of negatives? Oh my gosh. Look on the back of quiz 2. Remember we wrote some notes? Look on the back of quiz 2, wasn't it? Then we do some notes on whether you could take the roots of negatives. Raquel, put that thing away. If it's what? If the index is 3 or any odd number, it's okay. If its index is 2 or any even number, it's not okay. Why? Do you remember this? Negative times negative times negative. If it's, yeah, because these two will make positive, and then positive negative makes negative. That will always work if it's odd. If it's even, what's going to always happen? They're just going to go positive, positive, which is positive. So evens are non-real if it's negative, in negative radicand. So this is okay, and it's just going to be -2. Nice. Okay, so what are these steps? Number 1, convert to radical. Number 2, evaluate the root, and then apply the power. So I typically go that route. Okay, number 3, 25/4. What do you notice about 25 and 4? What list do they go on? 25 and 4 are on which list? The squares or the cubes? Square. So what do you think 0.5 is? 0.5 is the same as 1/2. 1/2 is the same thing as square roots. Do you remember when we split? Remember when we did stuff like this? You could split a product? Well, identical with division. You can split division. Okay? No, you square root both and then divide them, which is as low as it goes. You just work with them like they're integers, but it's a fraction, so you just work on the top, then you work on the bottom. Okay, next one. This is a fourth root or a third root. Which one? Fourth root of 81. And then once we get that, we'll apply a power of 3. Does anybody know the fourth root of 81 off the top of their heads? Abdur, no clicking, only thinking. Fourth root of 81. Sydney's got it. Anyone else? She whispered it. Oh, she said 3. Because 3 times 3 is, 81. Yeah. And then 3 cubed is 27. She's done so much homework that she's recognized 81 as a usual suspect. You know when you have a crime and you bring in the usual guys and you pick them out of a lineup? 81 is always on these questions. I don't know what you're talking about there, sir. Okay, next one. 0.75, do we need to break that one down, or you just know that 75 cents is the same as 3/4? So this is a fourth root or a third root? Fourth root of 16 to the power of 3. Sydney knows fourth root of 16. She asked me this. Attaboy! 2. Bop. Then you apply the cube, and you get 2 times 2 times 2 is 8. Math is fun. I love that comment. Ready? All right. Now some hard ones. Two minutes. Okay. You guys ready for this? Before we do this, we're going to back up right to the start of the unit, or start of the lesson, and we have to go back to elementary school. So in order to add fractions, guys, in order to add fractions, you have to have a common denominator. So 2/5 plus 4/5 is exactly 6/5. Now the next one, 2/3 plus a whole. If the denominator's 3, it's 2/3 plus 3/3. Do you agree? So that's 5/3. Now the next one, 2/7 minus 3/21. So how do I make 7 the same as 21? Times by 3 times by 3. So I got 6 over 21, take away 3 over 21. Whoa! Oh, your screen stayed the same. 3 over 21, which reduces to 1 out of 7. My little guy, I'm teaching him this stuff. He can do it. Yeah, my young man named Isosceles, yeah. He's 9. I named him Isosceles. I'm kidding. All right. The nice thing, guys, if you... Hey, listen up. If you hate doing that, the TI does it for you. Okay? And even the one that I give you, the scientific one, it does it for you as well. So you can cheat with your calculator. Okay? So if you don't like adding and subtracting fractions, hand up if you don't like adding and subtracting fractions. It's okay. It's a common thing. I'll teach if you need to learn on the calculator. Will you promise to ask me and I'll show you? Okay. Next one. Listening now. How do we multiply? What's the rule? Top to top and bottom to bottom. So this is 6 times 4 and 5 times 3. They both can be divided by 3, so you have 8 over 5. If you're multiplying by integers, just put a 1 underneath. Top to top, bottom to bottom. 3 times 4, 2 times 1. 12 over 2 is 6. And the last one is just going to be 8 over 25. Okay, so that's a little bit of review from junior high. Now let's take a look at today's stuff. All right, the first one. What do we do with radicals? This is going back the other way. So if we were to make a fractional power, what goes in the numerator and what goes in the denominator? What goes in the denominator? 4. What goes in the numerator? 2. This is the same as x to the 1 over 2. It says simplify by getting rid of the radical. So we just want to have a power. So this is like radical to power. Okay? All right. So here we have x8, y12. What's going to be the power for that guy? Yeah, what's the power for square root? 2 or 1/2? Yeah, because power 2 is square, right? So it can't be 2. So it has to be 1/2. We already decided that earlier. Those are the usual suspects. Just like make sure this, you guys know, is to the 1/2, okay? Yeah. Every lesson you should add to your study sheet the big idea from it. Attaboy. Okay, but we're not done on this one. Do you remember the grade 9 rule when you had a power to another power? You times it. So what's 8 times 1/2? And what's 12 times 1/2? Okay. Next one. All right, next one. X. What's the power for this one? The first one. What's the fraction? 4 over 4. Or 1. X exponent 1, which you don't have to... So does a fourth root cancel a power 4? And that's why. You just saw it. There's the proof. 4 over 4 is x to the 1. Okay, now what's the next one? What's this power here? 2 over 5 or 5 over 2? Remember, the index goes to the denominator, so this is 5 over 2. All right, back to grade 9. What do you do when you have the same base and you're multiplying? Flip back to your top of your first page. What does it say? Flip back to your top of your first page. Same base. You're multiplying. So what do you do with the powers? Add them. So there's a little 1 there. What is 1 plus 5/2? Well, it'd be 2 over 2 plus 5 over 2. 7 over 2 is the same as 3.5, correct? But we want to just leave it as powers. Next one, What do we do with x, y? What do we do with x, y? It goes to the power 2 or 1/2? 1/2. And then do you remember what happens when you have a power applied to a product? You put them on each. I didn't review that one. And the last one would be b to the 2/3. Yay. This you're going to have to practice. Homework's at the bottom. Okay, homework's at the bottom.